The mean value theorem, that is MVT, we want to find the value of c which satisfies the mean value theorem of differentiation. F of x is equals to x cubed minus 4x with c lying between -2 and 1. And by definition, the f prime of c is given by f of b minus the f of a all over b minus a. And we know that our value of a is equals and our b is 1. So based on the definition, then we can comfortably say the f prime of c is equals to f of b, that is f of 1 minus f of -2 all over 1 minus 2. 1 minus 2 is 3, and f of 1, remember f of x is x cubed minus 4x, so f of 1 will be 1 minus 4, then minus f of -2 will be -8 plus 8. When we substitute, f of x is equals to x cubed minus 4x. And so we have f prime of c is equals to -3 minus 0 over 3, and that means is equals to -1. F of x is equals to x cubed minus 4x, and therefore f prime of x should give us 3x squared minus 4. And given our f prime of c will be 3c squared minus 4, and that will be equals to -1. And this implies that 3c squared is equals minus 1 plus 4, and 3c squared is equals to 3. Dividing through by 3, this implies that c squared is equals to 1, and c is equals to plus or minus 1. Now we want to find out which of these two values will apply. We recall that c is an element of -2 and 1. Therefore, if we look at -2, -1, 0, and 1, we have -1 and 1. And since it's an open interval, then 1 is not inclusive. Thus, we can conclude that the value of c should be equals to -1, since 1 is not an element of -2 and 1. And for another example, we have been given our f of x is equals to x squared, with being an element of 1 and 3. So we know that the f prime of c is f of 3 minus f of 1 divided by 3 minus 1, which is 9 minus 1 over 2, which is 8 over 2, which is 4. So based on that, we can then get the first derivative, which is f prime of x, which will give us 2x, and therefore f prime of c, which is 2c, should be equals to 4, and this implies that the value of c, which is 2, and it is true because 2 lies between 1 and 3. We want to find the value of c which satisfies the MVT of integration, the mean value theorem of integration, and we have an example. We want to let f to map 1, 2, 3 into the real number system be defined by f of x is equals to x squared. So based on the mean value theorem of integration, what we have is the integral of 1 to 3 of x squared dx, which is x cubed over 3, 1, 2, 3, and this basically means it's 27 over 3 minus 1 over 3, which is 26 over 3. We should have noted this, that b minus a f of c is equals the integral of a to b f of x dx. That is the standard definition for the MVT. And so based on that, because we have already gotten one part, we can say 3 minus a f of c is equals to 26. 3 minus 1, because the value of a is 1, so it is 3 minus 1 f of c is equals to 26 over 3. That's how it should have appeared. So therefore f of c is equals to 26 over 3 times 1 over 2, which is 13 over 3. What we know is that f of x is equals to x squared, and therefore we can say that f of c should be equals to c squared, and this is equals to 13 over 3. And that tells us that c is equals to plus or minus the square root of 13 over 3. But we want to keep in mind that c is an element of 1 and 3. And we can clearly see from this we have negative 13 over 3 square root, or we have positive square root of 13 over 3. And out of these two values, it is only this value that lies in the interval of 1 to 3. Thus, we can conclude that c is equals to 13 over 3 square root. And that is the value of c for integration. I'm sure you're loving these videos. Please do subscribe.